So stop recording here. Let me just so so basically today's video started is my third recording as it is Otter AI. So Otter AI is here. So Otter AI is here. It's recording. Let me just try to get it into Otter AI. Should I go? Once again, guys, this is very important. So basically, I'm trying to record on Otter AI. Oh, my battery is very low. It's dangerously low. Yep, it's been too long. And that's how much more I have. It's like, how much percentage do I have? I have 52%. Oh, it's kind of like not that bad. 52 is not that bad. So what's the video on NSIGGI? NSIGGI or Wartech. So the video is on Wartech. Basically, I got the trunk up here already. Now, where's my? Yeah. So basically, this video is on NSIGGI Wartech. So basically, I got my pen here. So the NSIGGI Wartech is like basically it's not a toy. It's not a weapon. You can get the first release there on the thing. But I'm trying to first address the health and social care thing anymore. Because anybody anyone that's fighting should be careful. Like if you want to fight, just do yourself. So the water policies are kind of enforced. So you get the freedom to fight, freedom to work. But it's fighting freedom fire. But you don't be careful when you're doing a freedom fight. So you want to like basically the NSIGGI repository is a subject of concern. So basically you get a war. It's not a toy, it's not a weapon, so it's not a toy you play with it. You can't play with it. It's not meant to be played with. Toys are meant to be played with, but you don't play with toys. And it's not a weapon. You don't use it to do something dangerous or kill people. That's what NSIGGI means. So it's like it's a war tech, but it's for because it's meant to deal with other things. It's basically like a polyglot superior question protocols, because you can use it for basically it's a multiple use system. So basically you can use it like a weapon or a gun. Like a gun, you can shoot it, or you can shoot it. You can shoot it, but you can usually shoot it in a non-lethal way. That's kind of combination. It's like it's non-lethal agility, because if you shoot someone with a gun, you don't intend to kill them. You're liable if they die. Those kind of things are really the thing I'm trying to address in the NSIGGI version. Basically, the goal of this is like get children to actually use it. But Igbo children, but it's more like measures, countermeasures. Because if you shoot someone, an adult, you are a big person, you are liable. But if you shoot someone non-lethal, you can give a child a non-lethal, something that's non-lethal, to do something, but for something. But basically, if you're watching children, it's meant to be the child protection before prevention before cure, that kind of thing. Here, basically, basically all the things in the war, as a policy about, so you can't have a bed in the hospital, because when you stay on the body, you can exploit the services because you're really smart. So basically, there's no hospitals there if you're fighting a war, because hospitals are meant to care for you. You're not vulnerable because you're a war. You're dead. You're vulnerable. So I'm saying you only allowed in hospitals you only allowed things that are bound to your domain. I don't care what it's war or not. For example, you allowed upright bed. Because upright beds are like beds that have the way to go upright, so you can relearn to walk, because you're relearning to re-enable yourself. Re-enable yourself is like self-enable, because the bed, every time you come to the bed, you lie in the bed, but you have some kind of freedom, degree of freedom, the maximum degree of freedom to go 180 degrees, 180 degrees and 100. I don't care. 200, 270 minus 180 is what? Basically, you can rotate 3/4 of the way, and you can sleep on the other side of the bed. That's kind of thing I'm envisioning, because the bed is more comfortable, because you have the luxuries to get up the bed. And no matter how severe because not a 360 bed, it's a 270 routine bed. So this kind of thing I'm saying, you don't have a standard bed. It's still standard bed. That it's not bed for the hospital, because it's a policy. Because you are freedom fires, you're meant to stay there, get well, and get back into the community. There's no care homes. My constitution is a policy. There's no caring for people. I hate that caring. There's only enablement. There's no need to care for people who are neurodivergent. Even if you care people, I don't really care. But you know, the care is not care equals not equal to enablement. Care is not equal to support. Support is not equal. So you want to support something, you don't you give it assistance, assist. So support is not assistance. Advocacy is not assistance. Assistance is not support. Those kind of things. Those kind of things that coerce people. Basically, these are auxiliary properties. You know, these are clauses that you have to enforce. So. Bureaucracy, no bureaucracy. Don't you talk about bureaucracy? Basically, these are anyone that violates these lot of things, the disjoint rules, are violating something called constitutional violation. Basically, it's the federal councils, you know, when they're paid them money to do something, they do the job. That's kind of thing. Yes, it's basically a violation. And basically, it's a penalty to it. Basically, the company has sorted it out basically, but it's automated. I don't trust you guys because basically, things like corruption, giving people money for doing a job, more job better than before, on giving someone priority or something. Those are the things I want to stop. Obviously, anyone that's fighting should just get in. Never even get to the children's ward. You know, there's no children mixing people there. You know, just like you get into your units, you get your job done. You get, you know, what is a computer work, health care. Basically, you get health and social care, but you are the service. You come and you go. You get a jacket, you come, you wear your jacket, you go outside, you know, you continue your fight. You know, whether it's like joining the code or like, you know, it's temporarily, it's like a hostel. But hostels are like self-sustaining. So when the hostels don't lay in, doesn't you lay in because you know you don't need it. Because of things, based on your eligibility. Because you know there's no need to care for the jury, which is a policy. War is when was more optional, then you can start building around that foundation of temporary. Obviously, but you know you don't want anybody to be there indefinitely because that is like more of a camp. Because they know too much basically how it works. So it's like swappable systems that are sparse. Tomographically, basically the area is sparse tomographic. That means the hospital that can build on tomographic principles. The tomography is just the study of area of viewing parameters. So if you know a parameter, you have something of radar. What is up down, you know the area tomographically. That's tomography. You know the inside out because you know how it looks. You know, basically if I have a square, I know a square is a 2D object, but that represents some kind of 2D, like some kind of compound complex structure that can map out. So basically, that's what I'm saying. It's about NSIGGI video. You get the Risco. Basically, Risco is showing us that it's like basically it's not conscious. So basically, I'm trying to implement Cisco. But I love Risco too because Risco is like unibound telemetry. But you know, 6 is the standard for consciousness because I prefer a 6 core assembly. Because it's you get the motor system there. So basically, I'm trying to implement a motor system, but the motor system is not just for killing people. It's for payload delivery because you know it's sparse. It basically does the job. Basically, it's like counter terrorism. Basically, you know, basically maybe the motor systems is just are precision strikes. That's in the framework you go. You done Ebola. Basically they are fire and forget systems. If you find something, you forget it, you know, because you don't have to deal with it ever again. Maybe it's equipment, maybe it's blood change. You don't have to do. You just know what it is. You precisely okay. You do it once, it's done. Then you can continue your mission. You don't have to fire. That's the idea. So you get a motor strike, and you get the sparse topology of Nigeria because usually that's the basically the things to do with children too. The casualty, you get to build your own. Basically, I'm implementing. I already have the proof on my patterns repository, which is here. Am I ready? Here still. Here. So this is here. This is my YouTube channel. Obviously, you go here, you go to OBINexus. See all these links here. This is my YouTube channel. So you go on GitHub. Here, but I don't click on here. I go to here, I think. So this is the repositories here. So you get here NSIGGI, but you get all the polyglot systems here for V1, and you get the UAI. But I'm trying to build MOS for applications. But this is my poem. No, my poem, the other one. This is like a daemon migration, zero outage budget. This is like basically the how I set 5 for the basically this is like a union daemon trick. So you fork the union. But you know it's about this so you got the gating flow, but you know I'm saying to you guys, basically I got like a cruise missile, kind of sparse. It's a kind of cruise missile, but it's not doesn't leave any debris because it can basically it's a sparse cruise missile. So basically this video also was about. So it's like a missile, but it's sparse. So it's a cruise missile, but it's like you can take and can give, so it can replenish, and it can basically it's biological stable, so it can replenish resources or your resources, like your, because you don't need to divide the payload to the people. The missile knows what to do it, but it's based on some kind of model on the A-star scoring, which is like topological, tomographic systems, so sparse modeling. What does this mean? Basically, this is just the simplest model I've got for it. But where did I keep it? It should be here, Namdi. No. Dev.2. So basically, I should get Dev.2 article here. Basically, there's some kind of article I wrote on that. Basically, it's not here. Why is it not here? Basically, it's here. I haven't found it. Let me just try to find it. It's an ant stuff. The ant stuff here. Ant stuff. Yep. This is the ant stuff. Yep. So this is a. So basically, I can start a new one. This one. None of your business, guys. So this is this is fine. So this is the article here. Is it here? This is the article here, but it's like it's not really a fit to screen. Once again, guys, fit to screen, fit to screen, and then lock screen. So this article here is just like some kind of sparse to a graphic system, but it's mapped on the other one. So you get two sites. So this is for one distribution. You see how an art compares to a reality, but you usually of energy. So one input is scalar function. X is an error of a research mass lib parameter. So 1D3 the output. So you get like a mapping of this. You guys read this article, but it's based on Hamiltonian rotation. Basically, you got like some energy system. But you have the energy. Basically, you're trying to maximize resources. So this is a sparse cruise missile. It's like a cruise missile. It's under support system. It's 2-1 because it's kind of like this is 3-in-1 actually, but it's like it can heal itself, but it can heal its components. This is a model here. So you get like a cruise missile. This is a cruise missile. Think with an initial explosion here. But this is all there is to it. So this is like I see this going up. This is only going up. This is just the world going up, like me going to the sky. Basically, if I point the light upwards, that's up. If I point this way, it's like the right and right up, right. That's basically go up, right circle, and back. Basically, it's a cruise muscle, which is a precision strike, really, because it knows what it's doing. It's like it knows what it's doing. So it goes up, it goes right and down, and go back up depending on where you are. But you are here in the dot here, but it goes up like explosion. Basically, it doesn't really look at something that's like it's like a OBINexus differentiation system fallacy. So you go up to some kind of altitude, which is where the right angle line is, and that altitude is when you stop, and then you go loop. So the loop represents some kind of coming down. So when you go up, you have to change the speed, and the round represents the speed, and the speed, basically you double the speed, and that speed gets faster. So when you come down, basically the thing is already basically when the thing fails at this altitude, it's gonna fall down in pieces. So you let it drop down. Basically, it's like a shoot bullet in the sky, and the bullet comes down. It's harmless. That's the idea. You shoot a bullet in the sky, it goes up, it goes to altitude, it comes down, it fails, it goes down. It doesn't kill anything, it doesn't hit anything, it goes down, so it doesn't continue. So if it goes, if it goes this is one hoop system. So it goes up, it goes round, basically it spins round. Basically it starts going faster and faster. It starts like coming down. So we have to get the altitude. Basically when it gets to altitude, it starts to slow down. Because it doesn't need to go in the muscle. It has to like use the earth curvature, which is kind of the symbol there, and it goes down. Basically, he has to go down, up and down, but he doesn't think about it because he knows the energy to use. So it's basically using atmosphere to go faster and down. If it falls into basically it goes to make it fall down, but fall down in a way that doesn't kill you. Basically, you got this model here. Here, it looks like a cruise missile going up. Basically, it goes round in a bubble, round, and then it goes down. So when it hits this point, the middle point in the middle, that's basically you can't go back. It either falls, it all explodes at that point in space, which is halfway to the root. If it doesn't explode there, we shut it down manually because it's coming back to us. That means it's in our domain. Because the most part obviously if you didn't shut it down here, that means it's gonna fall to kill one of our own, or farm basically, or do some harm to one of our own. We pass this checkpoint, these two checkpoints, the altitude and the being in some other altitude that's not our own, a delimiter zone, it has to come down the opposite side and do the same thing. Do some checks. Basically you're looking for the target, but the target is just double, so it goes behind the target. It's like a flank. So it wants like a little maneuver. This is like this one hoop. system. So both the maneuver to hit the target, but the maneuver is sparse. So that's why basically, if this gets to the halfway point of the loop, you can now deliver the payload. But the payload can be to one resource. Basically you can split in three. So by splitting three, it's like three systems. You get three missiles in one. So you get like one missile that fires the enemy, fire and forget. You get the other one, forget and fire. So you get like fire and forget. You can fire, you can forget something and fire it, because you don't know it's a threat, but you fire it, but again the same thing. You get one missile that, but there's two missiles, so you get one and two. So that's the idea. So you get six missiles maximum. Forget two, one to fire, and forget, and get the other one, fire and forget, forget and fire. So that's the idea. And then the result, you get two missiles, one for that. You get another two missiles, like, some resources, so you get some food. So this is like things like packages or like delivery aid in the military zones. So you don't have to go back and get it. And you get one, two missiles for like a system in-flight, pre-flight fixing. Because it can be hacked basically. So you get two more missiles for hacking, but that's before. Basically, the engine can be hacked and we chase everything. Because we can learn from this system too. So it has to learn to sustain itself too. So it's like I get two for myself, two for basically the missile can be stolen, the payload, but you get four for that. Basically you get because you get like a four compartments for that. So you get this after turn into it can be into, so you get four, you get six. Not just it, to sustain this. So you get six things, but you get two engines, two engines. Basically you get three engines. Two engines for velocity, like a latitude, longitude, and another two for pitch, row, yaw. So you get six engines total. So you get six engines, but they are maneuvering. Usually the reactors, the axis system, they require an axis, a row, pitch, yaw, and rotate, X Y pitch, turning X. This is like a quaternion rotation of pitch, which is like a X Y rotation. The Y axis up down, and row, which is like the maneuvering. But it's meant to as maneuver systems that think they're intelligent, because we're moving towards ontology. So it's more like a cohesive swarm. But it's not swarm, it's just one component. It's just like one component can separate two and join back mid-flight. So we basically this is how you look like with shoots. So you see this one there. Okay, guys. So you get this one's like you start from here. Here. So basically the ground plane is where level. You can all shoot each other. So basically don't. Oh no! Oh, is that? So you get two hoops here. So you get two hoops here. Yeah. So this is the two system. So you can see, guys. Here. So you get up, right, down. So basically you start here, you go one hook there, two, but this is like half a hook, so you use half a hook to power up again, and get another big hook, and then powers up again. Basically the system is more for ground shape. If you have air defense and more defense, so basically you don't really know, because you get air systems, aero defense, and you get ground defense. So the money you get 2 hoops, 3 hoops, 4 hoops, it doesn't really matter. But you get interstellar hoops, because you get things that go up. So it's meant to maneuver all of that and just have the payload delivered. Whether it's the payload is not even like the weapon system, it's more of the thing you actually do. The payload can be food, or rations, or something that a relic, or some kind of something that's information, but he has to obey this kind of trajectory. He has to respect his own trajectory before he can respect anybody else's airspace. But it is like a derivative drone system, but it works because it doesn't think it knows what it's doing, so it can break into, it can destroy, it can drain, it can intersect stuff, but it's for humans who are actually doing it. So it's a mini drone. You get one, so basically it goes up, it takes a curve, it goes back. Basically you see this back, it goes back. So it goes back. And this is the diagram here, which I'm trying to use, and it goes up. It goes up. Basically, this goes back. This is where we are. It goes back. It goes and it goes does one big small hoop, and then goes back again, a little bit back to the start, which is in the front, and goes up again, and goes 2 hoops, and then does room 2, and then the last hoop is just the end point. So it does 2 hoops. Basically it does 2 hoops of jumps in the atmosphere, geometric lines with the axis, and then pop back down to the ground, because it's a precision strike. It's a mortar system really, but just more of a payload bound mortar systems. That's the idea. So the trajectory goes up and down, but it doesn't go up and down. It works on like gliding. So basically, you don't power it on. You power it on, but you don't want to power it on because that's a lot of information. You want to glide when you hit when you reach certain altitudes, especially when you go to deep space. Because it's really trackable, not trackable because it just uses the noise around it as a masking. It's a masquerade. It's a masquerade. Basically, it's masquerading because it knows what it's doing. Basically, for example, basically you get the two endpoints: 12 days pollution, 12 days. Basically, it's a payload system that's sparse. It allows you to deliver systems that are, but you can use it to deliver, return and deliver. So it's delivery looks like a Uber. It's like a meals on Hot Wheels, meals in the sky. What did the food aid is going to do two jobs in one. Because it doesn't need all the intervention. You just load it up, you kit it up, and you go. You send it to the right destination. Pollution. Basically, it's like a manual, so you can send it back. So basically, when you receive something, and you can intercept it, but what they don't know, So basically, there's some code, some security measures there. So when you see something, you can send it back, no matter what it is, because it's a really attack system. It's like opening and lock. But for this, you have to have some noise. So you get a medium, which is the atmosphere. So you can hack it because they are trying to hack it to with the real. So you get a no signal and no noise channel, which is just your medium of communication. Since there's no signal there, you have to interact that medium, and that's like the electromagnetic wave spectrum for the system. But people are trying to do this. Trust me, they are crazy people that want to do this. So you get a really effective system. So you get the noise stuff. Basically, before think of it like this. So you get an engine, like a motorcycle engine. You are the payload. But you are trying to go to somewhere basically. But to start the engine, you have to kick it, and you say run. But the fuel burns slightly, so you have to get it to burn correctly. But how do you get it started? You can pour water in it when it doesn't want to start. And now, as much as you get started, but you can pour it crazy and make it start. Give a jump start, which is like you switch the engines off, and then you have some kind of rule signal to you give it. So the jump start like a car jump start. You get the jump starter. But you got the engine jump start for the motorcycle. So before the motorcycle, you get you kick the engines and then you press the jump start button. So basically, two-way system, constant system that the system was it's like adhere to. But you have to make it basically. You're trying to make as much noise as possible, so you don't know what's being started, the car or like a motorcycle. But it's basically you have a motorcycle one, but if you get stripped out there, you get a lot of noise. That noise then protects the system from hacking or signal manipulation. In which that's the idea. You don't access this thing. So when you start the engine, you don't do the engine. You don't let the engine do something. You never let the engine start without the noise around the environment at the bare minimum. Because the noise is like some kind of masquerade. You don't know where it's gonna come from. It's like you don't know. It's like basically if you pick up some noise, you know where the noise is coming from. With like radio sonar systems, that's like that. You don't know where the noise is coming from because it's part of the noise. Basically, it's the noise of the noises. You put the right noise for the right system. Or for the wrong system, you have to guess wrong. You have to maximize their wrong guesses to your right guesses, so you don't So basically, it's a Missle system that works on determinism, non-deterministic pushing. What do I mean by that? One more thing. So basically, you guys want to take a picture of this. Can you see it? This is just a trajectory system, but the raw picture work on the matrix sensor. It's like a mesh topology that tomographic. That means you have to get the area of the curve under the curve to get the curve working. So the area on the curve is like the tomographic invariant, which is just the OBINexus. Basically, the measurement of the tomographic invariant is the system. So you get the most. So 1 over AB plus CD. So basically, get the determinant of matrix. No, the determinant of matrix is the conjugate inverse. So get them. So you get a plus b, a b, x y. You can get the conjugate of x y. Basically x y is one corner vector. The conjugate of that is 1 over yx. Y x of y 1 over yx, and this is the fractional equivalent of the unit model. Basically, if the determinant of matrix is 0, then you reach equilibrium of some kind of like OBINexus state. For example, one determine a matrix two coordinates A and B. I haven't got my pen. Let me try working out with you guys. I'm not smart, guys. I'm just like I'm not smart. I'm really smart. I'm not really that smart. So let me try working with you guys. So we get two numbers Yeah, but it's not numbers. You're working on matrices basically. We're gonna use calculus now. This my pen is here. Let me just basically get to a vector. Basically, you have to use the ODTS. ODTS is just to get the a linear equation. 2 3. 2 3 and 1 3. This is the matrix. So you get let's get 2 10. 2, 10, and 5, 6, which is the matrix. 5 matrix. This is the matrix. Now, determinant, you get the one, determinant is 1 over 2, 6, 2 times 6, or 1 times 10. So this is 1 over 10. This is the conjugate invariant, which is just the codeterminant matrix. So that's the rotation. Because determinant determines the axis of rotation. Basically, this determines the invariant, but I don't know what all the properties. But I know it's the right solution I use. So I'm trying to trace this as a models as a derivative. So 2x plus 10y equals some kind of a is related to it's basically a similarity equation to 2x plus 6y. Basically, because you get 2 points in space, and you get 1x plus 6y is equal to 1x plus 10y. So you get one. So this you get to derive some kind of summation equation. So the first trace function is this. So you get the 2 equations. So basically, I'm trying to give you the maths here. So these two matrices are related because when the summation is 0, there's no change. When the matrix is 0, the matrix is not 0. It's meant to be 2 times 6. So we get 2 summation is 0. How would it basically 2 times 6 is 12. 12. That's the x model, and the 1 plus 10 is 11. 1 times 10 is 10. So you get 12 10. 12 10 one domain. And this is determinant of 1 over 12 10. So the 12 1 over 10. This is not 0. That means 1 over 12 plus 1 over 10. Fractional equivalent. So that's 1 over 10. This is just a standard model of the determinant. So the unit model, the fractional equivalent of this is the fractional equivalent, which are called determinant matrix, is 1 over 10 plus 10, which is equivalent to 2, the same as 2x plus 10y equals 2x, we get same thing here. Version 2, 1, we get 3x because you add like terms, and they get 16y, which is the same thing in the fractional form. So you get 3x plus 16y, which is just the full sum, the addition of the matrix. They get 1 over, which is the function 1 of 1/12 over 110, 1 over 10, 1 over 10, 1 over 16, 1 over 16. 1 over 16 because you get 10 plus 1, so you get 12, 5, you get 5y because you add them, sorry, you get 5x on determinant, and you add 5x plus 16y, so you get 5x plus 16y, you get 1 over 5x, 1 over 5x, 1 over 5x, 1 over 15y, 5x, 1 over 5x, 1 over 15y, plus 1 over 50y. That's like this. So that's like that. Basically, 3x. This matrix is the same as this, but it's uniform. So this is like unique calculation. So I have to get some kind of functor that maps this 15y to the change for real-time calculation. So I know where I'm going based on observation of my state environment. If I've done it, this is basically active modeling for auxiliary reconstruction of state bound execution. So determinant matrix is just a very important one there, but it's both the more important. So my next move is to use determinant matrix to determine how the function grows via the OBINexus system. So if I'm going to some kind of if basically I have to calculate the derivatives now. So the derivative of this function at 1, it's 1. Basically, I get the whole one. I can calculate each different component, but each new component. I go a derivative we start to go basically the first derivative of 2x plus 10y. The first derivative d1 is basically I'm doing derivative. So derivative is x 0 to the power. So you get x to the power of 0. That's 1x. So you get x to the power of 0, and that's x to 0. And this is the step derivative. So x to 0 plus 0. X 0. So you get x. So d1 equals x. Because 2x. If you take the derivative of but the derivative of 1, but you get the integration. So we get the inverse. So you basically if you minus 1 from the power, you power it minus plus 1. Plus on basically you minus 1 from the power, and divide by a minus 1 from the number. So this one you then do the opposite. So you do, instead of minus 1 from the power, you do plus 1. Basically you do the inverse. You go to complete conjugate inverse. You get minus 1 from the power, minus 1 from the power, and then minus 1 from the power, and then minus 1, and then minus 1. So you get, so you add 1, so you get 3x. 1x, yeah, 1 was negative, and then you do the power to the power of 2, 3x to the power of 2. So this is integration. So basically, this mapping of the integration for 3x squared plus 1, 11, add 1 to the power of 1. To the power 11 to the power of 1. So this is 11. So you get 11. So you get 3x squared plus 11 is the integration of 2x. So you get two states you're working on. Basically, this is the area in the system based on some kind of Hamiltonian resolution. Or Eulerian graph based on the cycle model, because the solution path, you get some kind of change in there. So you're trying to literally reconstruct the path with the determinant matrix to ensure that nothing is lost. And the 0 is the determinant resolution when you get because if the determinant is not 0 and you're actively trying to state, you can lose coherence, and that's what you don't want in this kind of loop system. So basically, the loop system goes up and down, and the system can get confused on this path and direction. And that's what I'm saying to you guys, because you have multiple components to counter for. Because it's basically calculus for statistical systems. So you loop once. When you loop once, you are resolving a 360 system, a 360 loop, 60 angles polar system, and you're trying to model this as a simultaneous equation. Where you have unknowns, but the unknowns are known because you measure the state in real time. It doesn't know how to deviate from the usual partial derivative. So when I'm measuring the state of the first the current state, I know my origin or determinant. I already know the path to take. The further path to take, because I already calculated the trajectory ahead of time based on the noise around me, the information I'm getting in real time, things I'm observing with my sensors. That's the idea of the system. Okay. Thank you guys. Have a lovely day. I'm gonna upload the video now. So this is an OBINexus NSIGGI project. This is like a cruise missile, but it's a Sparse missile. So I call it a safety critical Sparse missile because it has many purposes, many use cases, and that's the idea. It doesn't have to kill someone. It doesn't have to. It's not a weapon. It's not a toy. Either. So it's meant to have. It's not what you're doing to use it to kill someone. You have to develop. You have to remove that component to ensure you never kill someone. That's the idea. Thank you guys.